Hello friends, welcome back. Hearty welcome to you. We'll continue with the examples related to integration of functions using trigonometric identities. So in the coming sessions, couple of sessions we'll be working on that before we move into integration by parts. So integral of sine to the power of 4x. So how to find out the integral of sine to the power of 4x? Let's try to solve this example. Now we don't have any ready-made function which can give us directly the integral of sine to the power of 4x. So the approach is always to convert the functions with a power. We have to convert them into a function of sine to the power of mx or cos to the power of nx, something like that, because we know the integral of sine mx or cos nx, but we don't know the integral of sine to the power of mx. So powers we don't know how to deal with. Okay, so we'll go back to trigonometry and try to get two formulas. We will use them. So what is sine square x? Sine square x is equal to 1 minus cos 2x by 2. One more formula which is also useful is cos square x, that is equal to 1 plus cos 2x by 2. Now we'll try to leverage these two formulas to solve this particular problem. So our idea is to get rid of these powers and get the function into a sin mx or cos nx function. So for that my next step will be, I will write sine square x whole square here. I will say sine square x whole square dx, that's nothing but equal to integral of, now sine square x we know is nothing but 1 minus cos 2x by 2 whole square dx. Now this you know is a minus b whole square, so we can do that easily. A minus b whole square equal to a square minus 2ab plus b square. So next step we will get this 1 by 2 out, we will say 1 by 4, then we will say integral of 1 minus cos 2x whole square, a minus b whole square, so it will be a square plus minus 2ab, a square minus 2ab, that is 2 cos 2x plus b square, that's equal to cos square 2x. So we are able to successfully convert the power from 4 into 2, but still this 2 needs to be taken care. So we will leverage the second formula which says cos square x equal to 1 plus cos 2x by 2. Then leveraging the same formula we can also write cos square 2x is equal to 1 plus cos 4x by 2. So as you are putting another 2 here, one more 2 will be coming here. We are placing 1 2, one more 2 will come here. So it will become 2 2s are 4. So this formula we can leverage. So now if we try to simplify, what will be our problem? Will be 1 by 4 integral of 1 minus 2 cos 2x plus, we know what to write cos square 2x, nothing but 1 plus cos 4x by 2. 1 plus cos 4x by 2. So can I say 1 by 2 plus cos 4x by 2? This everything needs to be integrated. Now let us do them separate. For that what I will do, I will take first constant 1 plus 1 by 2, 3 by 2. So I will say 1 by 4 integral of 3 by 2 dx minus 1 by 4 integral of 2 cos 2x dx plus 1 by 4 of integral of cos 4x by 2. So I can just keep it as cos 4x by 2, or I can bring that and say cos 4x dx. Now we will go to the next step. Now integral of 3 by 2 is 3x by 2, so can I write it as 1 by 4 into 3x by 2 minus 1 by 4 into 2 into cos 2x, integral is, you know that's a sin 2x by 2. Then what is left out is plus 1 by 8 into cos 4x integral is sin 4x by 4. We know that already, so we don't need to discuss about that. So 3x by 8 minus 2 will cancel. I will have sin 2x by 4 plus sin 4x by 32 plus c. So that should be my answer for integral of sin to the power of 4x. It's 3x by 8 minus sin 2x by 4 plus sin 4x by 32 plus constant. So the logic what we have, the approach what we have used is, we don't know the integral of a ready-made function. We know the integral of sin to the power 4x. There is no ready-made function for that. So we try to convert that into the functions using trigonometric identities where the power can be get rid of. So we can get rid of the power and we can convert them into constants and the functions of sin mx or cos nx. Then we know how to find out the integral of them very easily. So let's do one more example. We have to find out the integral of sin square x by 1 plus cos x dx. So now again the same problem. We don't know how to deal with this. When we have u by v type integration, we don't know what to do. So we have to simplify this and get rid of this denominator first. So I have to get rid of this denominator so that I can get them in numerator with the functions which I can integrate very easily. For that I will leverage the formula that sin square x is equal to 1 minus cos square x, which is in the form of a square minus b square. So I can write it as 1 minus cos x into 1 plus cos x. So leveraging that formula, my next step will be integral of 1 minus cos square x divided by 1 plus cos x dx. That's equal to integral of 1 minus cos x. Just now we have seen that we can write like 1 minus cos x into 1 plus cos x dx divided by 1 plus cos x. Now 1 plus cos x, 1 plus cos x cancels. We are left out with integral of 1 minus cos x dx. Can we separate them now and say integral of 1 dx minus integral of cos x dx. We know integral of 1 is x and we know integral of cos x is sin x, and we have a constant at the end. So the answer is x minus sin x plus c. So we see here the numerator and the denominator, we have a power and we don't have a easy function or a ready-made function for which we can easily find out the integral. So we have to leverage the trigonometric identity cos square x plus sin square x equal to 1. So we have converted sin square x as 1 minus cos square x, which is nothing but equal to 1 minus cos x into 1 plus cos x. You simplify them, you get 1 minus cos x. You separate them, you know how to find out the integral of integral 1 is x and integral of cos x is sin x. So let's go to the next one. We have to find out the integral of cos 2x minus cos 2 alpha divided by cos x minus cos alpha. We have to find out the integral of this. So what we will try to do now is we will try to leverage the transformations. So where we can convert the sum or difference into product so that we can simplify and see any known integral, we can find it out, convert that or transform that into. Now what is the formula we are going to leverage? The formula we are going to leverage is cos c minus cos d is equal to minus 2 sin c plus d by 2 and multiplied that with sin of c minus d by 2. This is a formula what we are going to leverage. So let's go ahead and write our first step. Our first step will be integral of cos 2x minus cos 2 alpha c and d. I have to do c plus d by 2. I'll write it as minus 2 sine 2x plus 2 alpha by 2 and sine of 2x minus 2 alpha by 2 divided by minus 2 sine x plus alpha by 2 and sine of x minus alpha by 2. We'll go to the next step where minus 2 will cancel. We can simplify this and write it as sine of x plus alpha, multiply that with sine of x minus alpha divided by sine of x plus alpha by 2 sine of x minus alpha by 2. Now if you are able to observe, we have sine of, let us say, x plus alpha is, let us say, 2t or something. We have sine 2t here and we have sine t here. Similarly, we have sine p here, and we know what is the formula of sine 2t. That is nothing but equal to 2 sine t into cos t. So we can leverage that formula and we can expand the numerator. So the next step will be, we'll write it as sine of x plus alpha is nothing but equal to, we'll write down here, or let me change the color so that there is no confusion. Okay, sine of x plus alpha is 2 sine x plus alpha by 2 cos x plus alpha by 2, and I have another for sine of x minus alpha 2 sine x minus alpha by 2 and multiply that with cos of x minus alpha divided by 2, and this whole thing I'll be dividing with now sine of x plus alpha by 2 and multiply that with sine of x minus alpha by 2. Now you can see that very clearly sine of x plus alpha by 2 and sine of x minus alpha by 2 will be cancelling. We are left out with, let's go to the next step, 4. 2 2's are 4 and we have 4 cos x plus alpha by 2 and multiply that with cos of x minus alpha by 2. Now, but we have a formula. If you try to convert this multiplication again transform into sum or difference, we have that 2 cos c cos d is equal to cos c plus d by 2 plus cos c minus d by 2, or can we say cos c plus cos d equal to 2 cos c plus d by 2 cos d c minus d by 2. That will be easy for you, I think, when compared to this, just remembering that formula. So let me just modify that. What I am trying to say, both of them is same only. Easy way to understand is 2 cos c plus d by 2 multiply that with cos of c minus d by 2, that's nothing but equal to cos of c plus cos of d. This formula we will try to leverage now. That's why we are just trying to recollect that formula. So we have product now. We will try to convert that into again sum back. So I will take, this is what I have to do. I will take 2 out and I'll say 2 into 2 cos x plus alpha by 2 cos of x minus alpha by 2 dx, which is nothing but equal to 2 into integral of this whole thing is nothing but cos c plus cos d. Our c is x and our d is alpha, so can I write it as cos of x plus cos of alpha? Seems to be reasonable, right? Cos of x plus cos of alpha. So we'll integrate them separate now. 2 into integral of cos x dx plus 2 integral of cos alpha dx. Now integral of cos x is sin x plus integral of cos alpha is x cos alpha, because you know cos alpha is a constant. Integral of 1 is x, integral of 1 dx is x, so I'll have 2x cos alpha. Remember, cos alpha is not a variable, it's a constant, so it becomes 2 cos alpha integral 1 dx, that is nothing but 2x cos alpha. Or if I take 2 common, I will have 2 into sin x plus x cos alpha. So it will be 2 into sin x plus x cos alpha. That should be the answer with just adding an constant. So let's do one more problem before we wrap this up and move to the next session where we will solve some more examples. We have to find out the integral of cos x minus sin x divided by 1 plus sin 2x. Now how to solve this particular problem using the substitution method and also using trigonometric identities. For that, what we will do, we'll first see how we can convert the denominator in with respect of cos x and sin x. For that, I will write it as integral of cos x minus sin x dx. So by substitution method, if you remember, you have to pick your function in such a way that when you differentiate it, the numerator should get cancelled out. So I want to have now which function, if you differentiate, you get cos x minus sin x. If I differentiate sin x, I will get cos x, so I need sin x. Similarly, if I differentiate cos x, I will get sin x. So I need to have sin x plus cos x somehow, either with a power or 1, so that I can say sin x plus cos x equal to t. Then when I differentiate, I will have cos x minus sin x dx, which will be removed by dt, and it will become very easy. So now what I will do now, one, how I can write it in terms of sin and cos. It is nothing but sin square x plus cos square x plus sin 2x. How you can write in terms of sin and cos, 2 sin x cos x. But if you observe, this is in the form of a square plus b square plus 2ab, which is equal to a plus b whole square. And that's a good news, because a plus b seems to be sin x plus cos x, which is what actually we are trying to convert that into. So we are happy. We'll go to the next step. We'll say integral of cos of x minus sin of x dx divided by, we have sin x plus cos x whole square. Now we took sin x plus cos x equal to t. We will say sin x plus cos x equal to t. We know that cos x minus sin x dx is equal to dt. We thought about that, that's why we have took this. So that's nothing but my next step will be integral of cos x minus dx will become dt divided by sin x plus cos x whole square is t square. Or if you just need one more step here, I can write down cos x minus sin x into dx equal to dt. So it will become now dt by t square. Now that's nothing but integral of t power minus 2 dt, and we know integral of x power n is x power n plus 1 by n plus 1. That becomes t power minus 2 plus 1 by minus 2 plus 1 plus c. That's equal to t power minus 1 by minus 1 plus c. That's equal to minus of 1 by t plus c. Now my t is nothing but sin x plus cos x. So the answer will be minus 1 by sin x plus cos x plus c. That should be that should be the answer we have to look into. So how we have solved this problem? We have been given integral of cos x minus sin x dx by 1 plus sin 2x. Now we know that if I want to use method of substitution, I should have my function such that its derivative is cos x minus sin x. Then I can kill this cos x minus sin x dx and replace that with dt. So my t should be differentiation of my integral of cos x is sin x, integral of sin x is minus cos x. So I need sin x plus cos x to be my t, so that I can differentiate and say cos x minus sin x dx equal to dt. Now our whole effort was how to convert this 1 plus sin to x in terms of sin x plus cos x. For that we have leveraged the trigonometric identity sin square x plus cos square x equal to 1. We see a square plus b square, but 2ab term is missing, and we have a good news. We know sin 2x equal to 2 sin x cos x. So we can convert that as a plus b whole square. We have dt by t square, that's nothing but t power minus 1 by minus 1 after I integrate it. So the answer is minus of 1 by sin x plus cos x plus c. So we'll continue with this examples in the coming couple of sessions, and we'll try to move over to most interesting part, integration by parts. If you understand it, that's very interesting and exciting to do problems with that. So we will look forward to that. I'll catch you in the coming session, next session. Thanks for your time and support. Bye for now, as always.